Hello everyone, myself Professor Kishan GS, Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. So today I will be dealing with the subject Material Science 18 MA 34 related to composite materials in Module 4, whereas we are going to target the topic called as production of fiber reinforced composites. So as the name itself suggests, fiber reinforced, here the reinforcement which is being targeted as a part of composite is fiber in its nature. So since we say it fiber, it means to say it has a elongated length as its specification, or it is a threaded like structure that forms fiber reinforcement as a part of reinforcement phase in composite material. So the term fiber reinforced composites can also be considered as fiber reinforced plastics, fiber reinforced composites, as well as fiber reinforced polymers, because whatever the material we select here, it will be basically a concept of targeting the plastics or the polymers in general when we target the fiber reinforced composites. So related to the manufacturing of composite materials, we have studied something related to metal matrix composites as a target phase, wherein the production is being focused in the last session. In case of metal matrix phase or metal matrix composite, the matrix was considered to be metal, whereas the reinforcement was suitably selected. So we had studied different types of manufacturing methods of metal matrix composites, but here we do have a specific types or specific category that deals with the opting up of different types of methods that leads to the formation or development of fiber reinforced composites. Basically, we have two categories. One is open mold, another one is closed mold. So what is the difference between open mold and the closed mold? As the name itself suggests, open mold and closed mold, it means to say that you are going to develop the material in an open platform wherein it is not enclosed or it is not housed inside a particular chamber. So in open mold process, we have different categories. So hand layup process, spray up process, bag molding process. Inside the bag molding process, we have three specific categories. One is pressure type, vacuum type, and autoclave type, and the last one being filament winding process. See, these are the different processes which are being considered under open mold, and opting for these processes is basically on the type of product what it is to be targeted or developed. Different products will be considered for different types of application, and developing that particular products or fabricating that particular products will be basically on the feasibility study on different types of processes which are available. Moving on with the closed mold process, wherein it has to be considered under a closed chamber so that the property or the product deals with the exact necessary parameters that is to be identified or targeted for the application. So pultrusion process, compression molding, injection molding, sheet molding compound, it is SMC, resin transfer molding, thermoforming, blow molding, and pulp forming. So these are the processes that usually takes place within a closed chamber, and hence it is considered as closed mold processes. So the open mold process and closed mold processes are to be structured such that a particular type of product is developed. So moving on with the study on the open mold process, we are going to study the hand layup process at the beginning. See, basically when we target hand layup process, as the name itself suggests, hand layup, it is the process wherein manually we are going to lay up the reinforcement and matrix phase and thereby form a laminate. So preferably here the reinforcement what we select for hand layup process will be of a cloth like structure. It will be a fiber in which it has been woven like a cloth like structure, which is preferred for the reinforcement phase in hand layup technique. So basically to out the hand layup process, it is generally targeted to develop the laminates or the composites which consist of multiple number of reinforcement which are embedded with the help of matrix phase. It is simply to say it is laminate composites are going to be developed when we target the hand layup process. So basically we should have a mold within which a cavity should be there, wherein the cavity should be exactly like how actually the shape of that particular product is to be identified. So since here the targeted product is a laminate, so we are going to identify the length and width, that is the geometry of that particular product is been identified, and that will be considered as the cavity inside the mold here. So basically what we do, instead of directly putting on the reinforcement and matrix phase, first we are going to apply a coat of gel onto the cavity. The gel coating on the cavity is considered to ensure that once the composite laminate or the composite material is cured, that cured laminate should be taken completely from the cavity, so that there should not be any residues of the material that will be retained in the cavity. So to completely remove the product from the cavity without leaving any residuals, a coat of gel will be applied, so that that acts as a layer that avoids the interaction between the cavity and the material upon curing or during the curing process. So once you apply a coat of gel onto the cavity, thereby what we do is we are going to identify the number of layers of reinforcement required based on the calculation. By the end of this particular module, we are going to even identify the calculation for that particular number of layers when we target laminates in the form of numericals here. So we will calculate the number of reinforcement or the layers of reinforcement required. So upon coating of the gel, you are going to place one of the reinforcement mat or a cloth like element onto the cavity. Thereby you are going to pour the molten resin onto it. So the preferred resin will be usually of epoxy or the polyester, epoxy or vinyl ester as such. So those are the preferred matrix materials when we target the process of hand layup. So that resin material in its liquid state will be poured onto the reinforcement, and with the help of roller you are going to use the manual assistance, so that you are going to press the roller onto the reinforcement such that the matrix phase which is poured on the reinforcement is distributed uniformly throughout the length and width of the reinforcement. Say for example, if it is a cloth of around 15 centimeter by 15 centimeter, whatever may be the resin wherein you are pouring, you are supposed to squeeze that particular resin or spread that particular resin onto the entire 15 centimeter by 50 centimeter cloth. So thereby what happens, once you roll the roller onto the reinforcement to distribute the resin, then again you are going to add one more layer of the reinforcement onto this particular material. Then again you are going to roll the roller on that particular layer, so that the resin which is present within the first layer of reinforcement gets squeezed up and gets attached to the layer which is put it onto it again. So thereby you are going to add multiple layer of reinforcement, and simultaneously the calculated amount of resin will be poured, and using the roller you are going to ensure that the resin is distributed and squeezed between the number of reinforcement layers which forms a laminate upon curing. So the calculated amount of reinforcement and resins are going to be spread uniformly, and it is to be rolled uniformly with a maximum pressure, so that it is squeezed as well as it is distributed, and thereby it results in the formation of a structure that constitutes the calculated number of reinforcement and the resin. So since you are using the manual power or the hand to lay up the reinforcement mat as well as pour the matrix and roll the roller onto it, the entire process is called as hand layup process. So once this particular entire calculated number of layers of reinforcement mats as well as the resin is being distributed or mixed together, it is let to cure for a particular duration of time. So the curing of that particular resin or the composite depends on whatever the promoters or the catalyst you added to the resin. So that promoters and catalysts or the accelerators lead to the enhancement of curing time for the composite material to form. So the catalyst, promoters or the accelerators are mandatory requirement for the resin to cure the composite laminate. So that will be the curing temperature upon which it is going to be focused. So this is something regarding hand layup process. Next, we shall study on spray up process. The spray up process is similar kind of process wherein we opt for hand layup process, but the only difference is that the reinforcement which is selected in the hand layup is of mat-like in its nature, whereas here the reinforcement selected is a single continuous fiber which is chopped into small pieces, or which is chopped into a very small length of its dimension. So here the entire setup along with the hand layup method, it consists of different items like the cutting units or the choppers. In fact, okay, we'll be having a tube like structures which is a passage for resin with catalyst one as well as with promoter another one. You can observe two tubes here. One of the tube consists of resin and catalyst, another tube consists of resin and promoter. The catalyst and promoter, as I have already said, act as a curing agents to enhance the rate of curing so that the composite material gets cured at the earliest. Okay, so here what happens, the continuous fiber or a threaded like structure will be derived from the fiber rowing. Fiber rowing is nothing but the number of rolls of threads wounded on a particular platform. So a thread will be derived out of fiber rowing, and that particular thread is called as continuous fiber. So you can just take the example of a thread which is being considered for the stitching purpose or in tailoring applications. So that particular type of example could be considered similar to this particular case. So the continuous fiber from the fiber rowing will be derived, and that particular continuous fiber will be fed on the support of roller so that it doesn't get damaged to its length or its dimension, and through the roller the continuous fiber will be fed on to the cutters that cuts the continuous fiber into chopped fiber. Means to say that it cuts the continuous fiber into a very small pieces or a very shorter length of its dimension. So that particular chopped fiber will be now considered along with the passage through the resin. So here observe two tubes, resin with catalyst and one resin with promoter. So the two tubes results in the movement or the feeding up of resin and the catalyst and promoter onto the chopped fiber, so that the chopped fiber, once it gets accumulated over the mold into the cavity, it comes along with the resin. So here we are not going to add or squeeze the resin as well as reinforcement as in case of hand layup technique, but here the chopped fiber will be made to pass through the resin, and then it gets to allotted or allocated into the cavity. Again here, as in case of hand layup technique, you are going to take the mold, you are going to apply the gel onto the cavity so that upon curing the composite material will not leave any residues onto the cavity. So onto the gel coated cavity, you are going to feed the chopped fiber through the resin so that the chopped fiber and resin, that is reinforcement and matrix, cumulatively get adopted onto the cavity. Once it gets adopted onto the cavity, thereby what you do, you are going to again make the roller to roll over the surface of the reinforcement and matrix so that it gets uniformly distributed over the length of the cavity as per the design. So here the chopped fiber comes into picture, and hence it is named as the spray up process, because here the chopped fiber is sprayed along with the presence of resin, hence the name spray up process. So the chopped fiber is the focus of study here, whereas here it is a mat like reinforcement material for hand layup technique. So this is about hand layup process and spray up process. Now let us study the bag molding process. So here in bag molding process type of open mold type of fabrication of fiber reinforced composites, so the preferred type of material are called as prepregs. See, as in case of hand layup technique or in spray up process, we had the layer or the identification of reinforcement in different types, as well as the matrix phase is being made to ensure so that it gets mixed with the reinforcement and forms the composite laminate. So in case of hand layup technique, it is a mat like structure of reinforcement upon which a pouring of resin or the matrix phase has been considered. Whereas in case of spray up process, the fibers in its longer length is taken and it is chopped into pieces, and this chopped fiber was fed along with the resin or the matrix phase so that it is cured to form the composite material. Whereas in case of bag molding process, the preferred type of reinforcement and matrix phase is generally considered as prepregs. So what do you mean by prepregs? Prepregs are the small pieces of reinforcement which are pre-impregnated in matrix, means to say that the reinforcement which are already coated with the matrix and it are cut into pieces or a small type of structure is called as prepregs. So whatever the combination wherein we take regarding prepregs, that itself is enough here to cure a composite material, and we don't need any of the additional matrix phase or the resin content to bind the reinforcement. So the preferred material for bag molding process goes with prepregs. So prepregs are the small pieces or the reinforcement which are already pre-impregnated with the matrix phase. So here we do study pressure bag molding and vacuum bag molding now. So in case of pressure bag molding, so this is the mold and this is the cavity upon which the type of product is to be developed. So here inside this particular cavity in the mold, we are going to have certain parameters which are as similar to that of hand layup technique. So again we are going to coat a gel layer on the cavity before we allocate the resin as well as the reinforcement as in case of hand layup or spray process. So inside the cavity we are going to coat a gel so that it doesn't leave any of the residues of cured or molded composite. So thereby what we do, you are going to feed this particular cavity with the desired amount of prepreg materials. So the prepreg materials will form over here, that is nothing but glass and resin layup. So this is a combination which is preferred when we target the pressure bag molding. Glass is nothing but glass fiber or ceramic glass, which is as applicable for the application. So that particular prepregs are being allocated into the cavity, and we have the upper mold which has the opening for the air pressure line, and will be having a rubber bag which is fitted onto the upper lid or the upper mold of the entire assembly here. So thereby what we do, you are going to keep this particular cavity filled with the prepregs, then you are going to make sure that the lid closes the cavity, and upon closing you are going to feed the air with a pressure of 1.4 to 3.5 kg per centimeter square. So that amount of pressurized air is being blown through the air pressure line from the upper lid onto the cavity, so that the rubber bag which is not inflated here gets inflated and results in the formation of the composite material based on the application of pressure onto the cavity or onto the prepeg which is forming the cavity. So thereby what happens, the excess amount of air which is present here will be sent through the opening which is sent as the vacuum. So thereby what happens, the pressure which is applied through the rubber bag onto the surface of the prepregs which is forming the cavity upon curing leads to the formation of the molded part here. So the pressure is being applied onto the specimen or onto the combination, hence the name it is pressure bag molding. Okay, so in comparison to pressure bag molding, vacuum bag molding is bit simple in its nature. So again here also we do have the cavity, and the construction of the bottom die or the mold remains almost same. But here instead of having the upper lid with the air pressure line, we don't have that. Instead we are going to have the vacuum line fitted with the pump here. Okay, so thereby what happens here is, so inside again the mold we have the cavity here, and onto the cavity we are going to apply a coat of gel. Again the purpose remains same, to not to get the residues of composite specimen after curing. So thereby what happens, a layer of the glass or resin or the prepeg is made to form over the cavity for a desired particular length or desired shape. So thereby what we do, we are going to have a covering of the flexible bag onto the formation or allocation of the prepeg into the cavity here. So upon this flexible bag, what we do is we are going to switch on the pump and we are going to evacuate whatever the amount of pressure or the air which is available between the composite specimen or the combination laid up here along with the flexible bag. So between the flexible bag and the layup of the glass and resin here, so whatever the air which is present, that will be evacuated using the pump. That is the suction of air particles which is present inside the flexible bag or between the flexible bag and the cavity will be taken out, so that the glass and resin layup, what it has been considered as a combination for the product development, thereby it forms the intact layer or the composition that leads to the formation of a composite material. What happens once the the entire vacuum which is present between the flexible bag and the cavity is removed? It is not that sufficient to form the composite material by drawing of the air which is present inside it, because to an extent the voids, the atmospheric air is the major concern wherein it needs to the formation or the curing of composite material. So once you start removing the excess amount of air present here, the voids that may result in the formation of composites, voids are nothing but the cavities or the holes or just a vent like unit between the reinforcement and the matrix. So that voids will be taken off and it will be ensured that only atmospheric air and atmospheric pressure constraint is being considered here, that leads to the proper curing of composite material. Once the excess amount of air or the vacuum is being driven out, then you are going to feed it with the normal atmospheric pressure onto the flexible bag, such that the gap between the cavity and the flexible bag, which is filled with the prepegs of the cured composition or of the composition that has to be cured, so that becomes a molded part that will be taken out for secondary treatment processes. So here we are driving the entire vacuum which is present here inside the flexible bag or between the flexible bag and the cavity here, whereas here you are going to apply the pressure through the rubber bag onto the specimen, so that it forms the mold cavity or the product forms the shape of the cavity as defined in the mold. So this is about pressure bag molding and vacuum bag molding. Now let us study the third type of bag molding process, that is autoclave molding. So autoclave molding is a combination of pressure as well as vacuum type of bag molding process. So here, we have to again recall the concept of utilization of the material, that is nothing but prepeg, as in case of vacuum as well as pressure type of bag molding process. So here the prepeg materials are considered in the autoclave process, wherein that material is subjected to pressure, heat and vacuum simultaneously in case of the autoclave molding. So hence it is considered to be the combination of pressure bag molding as well as vacuum type of bag molding process. So in order to go with the understanding of the setup here, so basically autoclave is a closed chamber wherein which the inside part is the cart which supports the platform, which supports as a platform for the prepeg materials to be piled up along the cart here, and onto the surface of the prepeg materials where it is being piled up, above to that there will be a vacuum bag which is placed above the prepeg. So the prepeg materials, what it is being placed on the cart, that will be covered by the vacuum bag, and that particular vacuum bag will be consisting of a tube line which is nothing but flexible vacuum line, and to that particular vacuum bag itself there will be a connection with the thermocouple, which is nothing but a device that converts heat energy into voltage source, or it's simply to say a temperature measuring unit in terms of voltage here, and thereby the sealed autoclave chamber. And here we do have the manual valve that releases the vacuum which is present inside the autoclave, sealed autoclave chamber onto with the help of vacuum pump here. So this is the construction of the autoclave process. So basically what happens, the prepeg materials are piled up along the cart here, and to that particular cart there will be a vacuum bag placed above to it, and thereby what happens, once you start the process of autoclave, you have to remember the pressure, heat and vacuum should be simultaneously applied onto the specimen, so that the entrained air or the air which is available inside the piled up prepared materials will be extracted, and thereby results in very fast rate of cooling for that particular specimen. So here what happens, so once this particular process is on, the vacuum bag which is placed above the prepeg will be taking out or suction, there will be suction of vacuum from the prepeg material which is piled up on the cart through the flexible vacuum line. So the vacuum pump is the device which helps in the suction of vacuum or the air which is present inside the chamber here in the autoclave. Once it is being subjected to the suction of or the extraction of air here, at the same time, okay, there will be heat supplied onto the chamber or onto the cart, such that the prepeg materials which is being subjected to suction of air through the vacuum pump will always be simultaneously subjected with the heat through the cart here, and thereby what happens, there will be suction of vacuum and there will be heat supplied through the cart. At the same time, once the suction of vacuum is complete, okay, in the intermediate stage itself, there will be application of pressure, so that the piled up prepeg materials will get its shape cured upon pressure application. So this is the simultaneous application of pressure, heat and vacuum over the prepeg materials which is being piled up on the cart. Okay, hence the process is called as the combination of pressure type as well as vacuum type, and the process is autoclave process. Just remember, you will be resulting in the suction of the vacuum present inside the chamber with the assistance of vacuum pump, and simultaneously will be applying the pressure onto the specimen or the prepeg materials which are present above the cart, and simultaneously you are going to heat the cart so that it releases the heat onto the prepeg materials, and the same composite material, the prepegs which is piled up, will receive the heat energy while it is being subjected to pressure along with the suction of vacuum. Hence everything will be simultaneously fed on the specimen, that results in very fast curing of the composite material. So this is about the first condition of the bag molding processes for the session. Next we shall study the filament winding process. So the filament winding process is extensively identified for its varied application in the development of products like the pipes or the water containers or the bottles. So here basically what happens, the PVC pipe, what we generally consider for the sanitary applications or some piping areas wherein the wires is to be considered, that is where the major application of filament winding process is being extracted. If you can just observe a piece of PVC pipe, and if you just start applying a load, or if you just initiate scratch on the PVC pipe, it comes out in the form of thread. So that is one simple notification wherein you can say it is made out of filament winding process. So here in case of filament winding process, the entire constructional principle goes with the major part that is called as mandrel here. So in this particular figure, the cylinder like structure what it is being shown is the mandrel. The design of mandrel will be such that it looks like, or it is to be the design of exactly the inner part of the product which is to be developed, because using filament winding process you are going to develop the product which is hollow in its nature. Means to say that you will be having a periphery or a surface, and within the surface it will be a cavity. So the inner shape of which the hollow product is to be developed, so that will be the exact shape of the mandrel here. Okay. So in this particular construction, you can also observe the rotary motion being provided onto the mandrel with the assistance of axle here, and there is a carriage which is assisted by the roller support, such that along with the rotation of mandrel, the carriage separately moves or slides over the direction horizontally, so that the material gets deposited on the mandrel during the rotation of mandrel. So observe carefully. We will be having a reel of glass fiber or the fiber since it belongs to fiber reinforced composite specimen manufacturing, it has to be a fiber in its nature, that is the reinforcement. So the glass fiber in the form of reels will be drawn through the tensioner so that it gives exact tension onto the material before it gets into particular shape or it takes particular shape. So this reel of glass fiber will be passed on to the rollers and extended along the tension force so that it results in the exact value what it is being targeted for the application. So that particular roll of glass fiber will be made to pass through the resin bath, means to say that the roll gets passed through the resin bath so that the entire surface of the glass fiber gets coated with the resin. So resin is basically selected again based on the type of curing what it is being targeted. So the glass fiber upon passage through the resin bath, okay, the same glass fiber along with the epoxy or any kind of such kind of matrix that is resin coated onto its surface will be made to get onto the surface of mandrel. So here the mandrel will be continuously rotating along particular direction and the glass fiber which is coated with the matrix or the resin will try to get deposited on the rotating mandrel along a particular structure. And this particular formation of glass fiber which is coated with the resin onto the mandrel is considered throughout the length of the mandrel by moving the carriage along horizontal direction. So the direction of control for carriage is basically upon type of formation of reinforcement direction. So if it is to be a straight, the control of carriage will be along the straight path. If it is to be on this particular hatched or crossbar link like structure, again it is the control on the carriage. So the movement of carriage results in the formation of resin coated glass fiber onto the mandrel. Once the deposition of the glass fiber which is coated with the resin on the mandrel is complete over the defined thickness, okay, at that particular point of time, the mandrel's rotation will be stopped and supply from the glass, the carriage, that is the glass fiber coated with resin from the carriage, both the rotation of mandrel and the supply will be stopped, and thereby what we do is we leave the mandrel to cure or cool to a particular time. So that curing time over the mandrel results in the curing up of the reinforcement and the matrix which is formed over the layer. So thereby what we do, you are going to take that particular cured material on the mandrel to be heated in the oven so that the mandrel gets separated from the structure, and thereby we are going to get the halo structure, something like the pipe wherein we use for sanitary application. So this is where the filament winding process is being considered. Remember, glass fiber acts as a fiber reinforcement here and it is a filament, and since it is made to wound along the surface of the mandrel for a period of for a defined thickness, hence the process is called as filament winding process. So this is something regarding open mold processes related to the fabrication of polymer matrix or fiber reinforced composites. Thank you.